All right, so now just doing lots of derivatives. So I'm gonna be looking at page 181 of your text. So textbook, chapter 3, page 181, because that has like just a ton of derivatives to do. So this is also like, you know, suggested practice. Suggested practice would be all the odds except number 21. Number 21 requires a technique that we're not going to learn. For some reason, that's the only problem that has that. All right, so I'm going to go through all the evens. And so if you want, you know, you can try some of the evens and then look at what we got here. Or you can just look at all these even examples and then try some odds. However you want to use it, you know, it's up to you. This is just for you. All right, so number 2, a nice straightforward one, 3 minus 7x cubed plus 3x to the 7th. So this is just power rule. So you're just going to say y prime, or you could say dy dx, your choice. The 3 is going to go away, and we have negative 21x squared plus 21x to the 6th. That's it. Just multiply, drop at 1. All right, number 4 says y equals 2x plus 1 over 2x minus 1. So what rule do we need? Yeah, we need quotient rule. Now, one thing you should look for is there some way I could simplify this so that I would not have to use quotient rule? Like if this were just 2x here, then I could split this into 2 separate fractions, which would simplify nicely and it'd be easy to do with power rule. But because there's a plus and minus in the denominator, I can't do that. I have no choice but to use quotient rule. So this is going to be f, this is going to be g, f prime is going to be 2, g prime is going to be 2. We want to remember that that quotient rule is going to be f prime g minus f g prime over g squared. So that means we're going to do y prime equals f prime is 2 times 2x minus 1, 2 times 2x minus 1, if I can write that. And then minus fg prime. You know, we should watch for signs and how things distribute and everything. 2 times 2x plus 1, that's fg prime, over your denominator squared, which is 2x minus 1 squared. All right, if this is a free response on the AP exam, you can just leave it like that. For my quiz, I'd like you to simplify this as much as possible. 4x minus 2 minus 4x. Is it minus 2 again? Yeah. Over. However, 2x minus 1 squared, we'd like to leave that because we like factored forms of polynomials. All right, now the 4x's cancel, so we just have negative 4 over 2x minus 1 squared. All right, that's all there is to that one. Moving right along to number 6. So number 6 says s equals cotangent of 2 over t. Now they write it like this. I hate this. The 2 over t should be in parentheses, but you know, I get where they're coming from. It's just, to me, it's not nice. So s prime is, okay, so I have one function inside another. I can clearly see that by the parentheses. That's telling me I'm going to use the chain rule. All right, so I have to start by doing the derivative of the outside function, keeping the inside function the same. So I have to know what the derivative of cotangent is. Do you know it? It's negative cosecant squared. All right, but we keep that inside function the same, okay? So in that first step, we're keeping the inside function the same. Now I have to do the derivative of the inside function, all right? But to do that, I mean, it's a little tricky because it's 2 over t, right? So let's think of that g as being 2t to the negative 1. So that means that g prime is negative 2t to the negative 2 using the power rule. And then I could rewrite that, since this is like this, let's rewrite it as negative 2 over t squared. All right, so I have times negative 2 over t squared. These two cannot combine in any way because I'm taking the cosine of this, or the cosecant of this, but not this. However, the negative can come out to the front, and so then I could write, and it's also, most people would write the 2 over t squared in the front, although that doesn't really matter. Cosecant squared of 2 over t, and that's your simplest form for that one. All right, that's number 6. I think I can squeeze one more into this video. So for number 8, I have y equals x. All right, it says x square root 2x plus 1. So the first thing I'm going to do is keep it y. I'm not going to do calculus. I'm going to do algebra, and I'm going to rewrite that root as a fractional exponent. All right, now I'm going to say, we got two things going on here. I got a product and I got a chain rule. because this part of this product has parentheses around it. So this is going to be a chain, but the whole thing is going to be a product, right? So I got one inside the other. So the product is sort of outside the chain, so I'm going to do that first. So now I'm going to do the calculus and say y prime, and I'm going to say this is f and this is g. I need f prime g plus f g prime. So f prime is 1, g I just copy it, plus for f I can just copy it. Now I got to do g prime, and this is where I have to do chain rule. So I'm going to do the derivative of the outside function. So that outside function is the power rule, right? That's my outside function. So I'm going to do 1 times 1/2 2x plus 1, and then I have to drop this exponent 1, right, and minus 1. So that's going to be to the negative 1/2 power. All right, but since this g, when I did the derivative of it, had an inside function, I have to go times the derivative of the inside function. That's the chain rule part. So I'm going to go, usually I call this g prime, but since I already have a g prime, let's call it h prime. All right, and what's the derivative of 2x plus 1? It's just 2. So that's that one. Now I should just try to simplify it as much as I can. So I have 2x plus 1 to the 1/2 power plus, oh, the 1/2 and the 2 cancel out. So I have x times 2x plus 1 to the negative 1/2. Since my question was originally phrased as a root, maybe I should write this as a root. Square root 2x plus 1 plus x over square root 2x plus 1. Sometimes you can do a lot of simplification with like multiplying the top and bottom by square root 2x plus 1 and trying to find a common denominator or something. But we're not going to bother doing that. We're just going to say that's number 8.